Welcome to ArcGIS Pro SDK for .NET, beginning Pro Customization and Extensibility. Next to me is Uma Horano. She's going to talk, we both on the Pro SDK team. You've probably seen us on GeoNet if you go to GeoNet. If you're not going to GeoNet with your questions, you should. So maybe that's the first note of today, GeoNet as our public forum. My name is Wolf Kaiser. I'm also on the Pro SDK team. Uma is going to take us away with the first pattern, and then I'm going to do a few demos for you as well, a little bit more advanced, but all beginning of the customization extensibility.
Good afternoon, everyone. Here is the session overview. I'm going to begin with some basic information on the two main extensibility patterns of the Pro SDK, the Pro module add-ins and the managed configurations. We're also going to learn about the declarative markup, DAML, the module class file, and the configuration manager class file. And then Wolf is going to take over and dive into more DAML and the asynchronous programming patterns required for programming with the Pro SDK. The ArcGIS Pro SDK for .NET extends the Pro application using the .NET framework. There are three extensibility patterns that are available: the Pro module add-ins, the managed configurations, and the plugin data source, which is new at 2.3. The SDK offers a collection of project and item templates. You can install the SDK from the Visual Studio Marketplace, and you can install it directly from within Visual Studio. We currently support versions 2015 and 17. An important thing I want to mention here is that the Pro API comes with Pro out of the box. They're available as file-based extensions from Visual Studio. Nothing is registered in the global assembly cache. They're available in the bin extensions subfolder in the Pro installation location. Here are some of the key features and patterns of the Pro SDK. It's built for the 64-bit platform. The UI is written using WPF, which stands for Windows Presentation Foundation. The programming pattern used is MBVM, which is the model view model pattern. ArcGIS Pro is a multi-threaded asynchronous application. So when you extend it using the Pro SDK, you have to work with multiple threads. Wolf is going to cover asynchronous programming patterns in the second half of this session. So what is an ArcGIS Pro add-in? It is one of the extensibility patterns of the ArcGIS Pro application. You use an add-in to modify the existing features and functionality of Pro to suit your custom workflow. ArcGIS Pro elements such as buttons, tools, dock panes, they're all extensibility points. They're all available for your add-in development. The Pro SDK offers item templates for pretty much all these UI elements. Here on the screenshot, you can see an example of the possible UI customizations that you can get with add-ins. In Visual Studio, when you create an add-in project and you compile it, you get a compressed Esri add-in-x file. So this gets deployed in your user profile documents folder. You can see the path, full path here at the bottom of the slide. So this folder is a well-known folder. What this means is when ArcGIS Pro launches, it will load all the add-ins that it finds in this location. We're going to see that in the demo coming up. When you work with ArcGIS Pro add-ins, there are two basic things that you start with: the config.daml and the module class file. So add-ins use a declarative framework to define their UI elements. So the config.daml file in an add-in is where you define these UI elements using an XML syntax. Again, we're going to see this in the demo coming up. So the module class file in an add-in is the hub and the central access point of your subsystem. So if you want to access any functionality within an add-in or your subsystem, you start with the module class file. It's very similar to the extension objects used in the ArcGIS framework, if you worked with that before. And it's a singleton instantiated automatically by the framework. Okay, let's go into a demo. I'm going to show you how you can use a Pro SDK to create an add-in. So here I have Visual Studio open. I've already installed the SDK. So I'm going to create a new add-in project. From the File menu, I go New Project. I expand the ArcGIS folder and select ArcGIS Pro Add-ins. Here I have my 3 extensibility patterns: Module Add-in, Manage Configuration, and the Plugin. So I'm going to create an add-in project. I'm going to accept the default for my name and my location and click OK. So now Visual Studio is stubbing out an add-in project for us. So this is how the Solution Explorer looks. I'm going to expand the References folder. Notice all the references to my Pro assemblies that are populated here. These assemblies are all in the bin extensions folder of your Pro installation location. They're all file-based references. There's nothing registered in the global assembly cache. The file that you see here open is a config.daml. This is where you define your UI elements. The add-in info tag here has an ID attribute. Notice that it's set to a GUID. This GUID uniquely identifies this specific add-in. Then within this tag, notice a bunch of elements. These help you provide some metadata for your add-in, things like name, description, company, etc. So here within the insert module, the ID attribute is set to my module's ID. The important thing here is a class name attribute. It is set to my module1 class file. This is the same module class file that we discussed in our slides. Here you can see tabs, groups, and controls. They're already pre-populated for us. This is where you would host your UI elements. Notice the appears on add-in tab attribute within the group element. It's set to true by default. This is a quick and convenient way by which you can get your UI elements on the Pro ribbon. I'm going to show you that when we run this add-in. So again, here is a module class file stubbed out by the project template. Okay, so now to this project, I'm going to add a Pro button. So I'm going to do that by right-clicking the project node and selecting Add New Item. I'm going to expand that same ArcGIS folder, select the ArcGIS Pro Add-ins subfolder. Here you can see all the item templates that are currently available with the Pro SDK. These correspond to the various UI elements that you can add. Your buttons, palettes, combo boxes, dock panes, etc. They're all listed here. So for this demo, I'm going to add a Pro button element. I'm going to call this my add-in demo button. So here is my add-in demo class file created by my item template. Notice that this is my button, and it inherits from ArcGIS Pro Framework's button base class, if you can see that IntelliSense. So the template has already stubbed out the on-click override for us. This is where you would add your own custom workflow. For this demo, I'm going to add a simple message box. Okay, so now when I go back to my config.daml, notice this button element that has been defined here within my controls group. This is done again by the SDK item template. The important attribute here is the class name attribute. This is my add-in demo button. It references the add-in demo class file that I just showed you. So now I'm going to compile this add-in. This is my documents folder, my user profile location. When I compile my add-in, notice this GUIDed folder that has appeared here. This was created by my compilation. So this GUID corresponds to my add-ins ID that I just showed you in the config.davo. So now when I browse into this folder, notice my Esri X add-in file. This is my compressed file, and Pro will load all add-ins located in this folder. It's a well-known folder. So let's see that. So back in Visual Studio, I'm going to launch the debugger. This will load Pro. And then I'm going to just open a very simple project. Now notice the add-in tab here. This was created by our add-in because I set my appears on add-in tab attribute to true. So when I go into this tab, you can see that our button was hosted over here. So when I click it, you get a simple message box indicative of a custom workflow. So this was just a quick demo to show you how you can create an add-in project using the SDK. Now let's go back to our slides. Stop debugging first. Okay, moving on to managed configuration. So a configuration is very similar to an add-in, and it allows you to design a version of Pro that's very streamlined. So it has all the functionality of an add-in, plus the ability to modify the Pro startup experience, such as your application title, your icon, your splash screen, start page, about page. And you can also customize the UI at runtime. So here on the slide, on the left, you can see the default start page for Pro that you're all familiar with. On the left, you can see the custom start page that you get out of the box with the Pro SDK. I'm going to show you that in the demo coming up. So when you compile a managed configuration project in Visual Studio, you get a compressed Pro config.x file. So this gets installed into your user's documents profile location. The full path is given here at the bottom. So how do you run a configuration? You run a configuration on the command line using the /config argument. Here on the code snippet at the top, you can see how the Acme configuration is passed on the command line. So you can install multiple configurations on your machine, but only run one per instance of Pro. So an important class here is a configuration manager class. You're going to define that in your DAML, and it contains a series of callbacks. And these callbacks help you to customize Pro's startup experience. For example, your application title, start page, etc. So all these callbacks are optional. So if you don't want to customize a specific startup experience in Pro, you can just not implement the callback, delete it, or return null. Okay. So let's see what you get out of the box using the configuration manager template. So here in Visual Studio, I've already created a configuration project using the template, and I've made no changes to this project. So this is how the Solution Explorer looks. You have the same config.daml and the module class file that I showed you in the add-in. Here is the UI folder. This has a series of user controls, the About page, splash screen, and the Start page. So you can use these out of the box, or you can customize it for your needs. The file open here is a config.daml file. Notice the configuration element. It has a configuration manager child element, and its class name is set to the code behind file that's going to implement my configuration manager, which is this file. So this is my configuration manager class file. This is my configuration manager, and it inherits from this base class, which is Pro's configuration manager. So here are my callbacks. So let's go through each one of these. This is the application name property override. So if you want to modify Pro's application name, this is where you would do that. Here, by default, I'm using Pro configuration 1 as the application name. Similarly, here is my icon property override. And if you want to change Pro's icon, this is where you would return your new icon. And here are my callbacks for start page, splash screen, and about page. So within the onShow start page callback, notice that I'm returning a start page user control to the Pro's framework. So start page is a view model pair. So we implement MVVM over here. And an important thing I want to mention here is that if you customize Pro's start page, it is your responsibility to initialize a Pro session with a new project or an existing project. We can see that in the demo too coming up. So here is my splash screen callback. I return a new splash screen user control to the Pro's framework. And similarly, within the About page callback, this About page user control that I return to the framework gets injected into Pro's backstage. So at this point, I can go ahead and add any of my UI customizations. I can add dock panes, buttons like we did before. You can add any of those item templates to this project. So I'm going to build this project and then run the configuration. Notice my custom splash screen. And this is my new startup page. The application name has been changed to Pro Configuration 1, which was the default, and I have a new custom icon. And I'm presented with a collection of existing projects that I can initialize a Pro session. So I'm going to pick this. And when Pro launches, notice that the application name and the icon is carried over here also. Now, when I click the Project tab to access Pro's Backstage, then I'm going to click the About page. Notice the text Pro Configuration 1. So this was injected by our About page customization. So this was a quick demo to show you what you get out of the box from the SDK Configuration Manager template. Now back to the slides, and Wolf is going to take it away.
All right, thanks, Uma. Is this on? No. Is it on now? Yes, thank you. Yeah, if you've seen the plenary demo today that Uma gave, she actually was showing a configuration, and there you saw the capabilities of a configuration where you can manage the whole UI. You can create your own ribbon with your own tabs. So that's one of the advantages of doing a configuration. So I'm going to talk a little bit about the declarative markup language for Pro User Interface Elements, DAML. Uma elaborated on that a little bit earlier. I'm going to dive a little bit on this. So ArcGIS Pro is using a declarative markup language. DAML stands for Desktop Add-in Markup Language. And it's used for all UI elements in Pro. Buttons, dock panes, galleries, property sheets, tools, whatever there is, whatever UI elements you have is defined in DAML. DAML is using an XML syntax, and by default, it's stored in a config.daml file. You saw that earlier in the demos. If you use our project templates, by default, you get a config.daml file. But it doesn't have to be that name. When using DAML, you can add, modify, delete any user interface elements. So that's important, and we're going to show that in the upcoming demos. Pro is also using DAML internally. So it's not just that DAML is there for add-ins, but Pro uses it for all its add-ins, its extensions. And you can look in the bin extension folder wherever you installed Pro to see what Pro internally does with this. So we're going to take a quick look at that folder. I should have it open. So if you hopefully that's big enough for you guys to see, but if you drill down into your Pro installation folder, there's a bin folder with all the main DLLs and the executables. And then we have an extensions folder where you have all the extensions that we have within ArcGIS Pro. One of them is the mapping extension, and we have the add mapping DAML in here. This is where all the user interface elements for the mapping extensions are defined. We're going to take a look at that real quick. Just a quick overview. I have that open in Visual Studio. And you can see this is pretty much the same what you saw earlier when Uma showed you one of those DAML files. We have this, this header, the ArcGIS header, that references the default assembly, which is ArcGIS Desktop Mapping DLL. So if you want to use mapping, you will have to include this DLL, but if you use our templates, that's all stubbed out for you automatically. And then we have all the different types. We have the module tag that Uma outlined earlier. We also should have our toolbars. We have mini toolbars, tab groups, groups and buttons, etc. We're going to take a look at that shortly and see if we can make use of this existing functionality within ArcGIS Pro in our own add-in. So let me close this. I'll go back to the slides. Again, here's a little screenshot of the DAML. You've seen it earlier. So one important thing is that DAML is transactional. There is 3 distinct actions: insert, update, and delete. So what happens is if you insert a button, you can come on later and you can update it, and then finally you can go ahead and delete it. And what that allows you is to modify Pro's user interface through your add-in, because it is transactional, it's not static. So the type of the action itself is determined by the element name in your DAML. So you would have update module if you want to change any kind of module. You have update group if you want to update a specific group of buttons. You have delete button if you want to delete a button. So below is a little code snippet. Again, I'm using the Esri mapping extension that I reference here. So what I specify in my DAML is I say, I want to update a module, and the module I want to update is the Esri mapping module. And specifically, I want to go through the groups that exist. Now, groups you might not know, buttons are grouped together in what we call groups. So if you look at the screenshot on the bottom left, you can see what's called the navigate group. So this is one group of buttons under the mapping extension that allows you to navigate through your map view. And specifically in this DAML snippet up here, I want to make an update to a group. In this case, the Esri mapping navigate group. So the same group you see down here, I want to make a change to. And the changes I do is I want to delete a button. And in this case, I reference the button with its ID. This is called Esri mapping bookmarks navigate gallery button. And I want to remove this. So you can see here on the right side, once I execute this, the existing mapping tab has been modified where the navigate group now is missing the bookmarks button. It's gone. We have the the fixed zoom out buttons, and then we have the go to XY button. So the bookmarks button is not there anymore. And now I'm going to further modify it by inserting my own button that I define in my own add-in. And this button here, we're going to see it working later in our sample. I refer to as toggle state button, and we're going to explain that a little later. So I'm going to have a little button that I inserted here that we use later in our demo. Okay, how do we use the DAML to change the UI of other add-ins or of the existing Pro UI? So we already learned that the DAML is transactional, and it is processed in the order of the Pro extensions or add-ins, how they are loaded. So it's kind of a first come and then be replaced by the follow-ups. So the last transaction will always win. We're going to see that later. So here's a transaction example. So I'm having, in this case, the Esri mapping zoom to full button. So this is the button that we have on the mapping navigation group that allows me to zoom to the full extent. So the mapping extension is loaded and the zoom full button is added. So you see a little excerpt here. This is the DAML that I actually copied out of the mapping extensions DAML. So if I look through that file, somewhere in there I can see button, ref ID, Esri mapping, full zoom button, and the size is small because if you look on the UI, you see it's a small button. So it's been added here. So now it's been added to the UI. Then we load a custom add-in, and now we want to delete that very same zoom full to full extent button. So I say in my DAML, I specify update the group. I specify the group of buttons where I want to make my update, and I say delete the button and specify the ID of that specific button. And then here once more, in the DAML transactional model, the last transaction wins. So if I am the last one and I say insert button, that button is inserted. If I'm the last one and I say delete button or modify button, that's what's going to happen. And we'll do a demo to that regard. So how do I ensure the proper DAML processing order? Clearly, if I want to make a change to the mapping user interface, I have to make sure that that comes before my add-in is loaded. So in order to ensure this, I have to make sure that I have the proper processing order. In your add-in, if your add-in changes another add-in or a pro extension, you have to use the dependencies tag in your DAML. So if you look at an add-in example, for example, that changes the mapping extension, so we have a dependency on add-mapping.daml. That's the name of the file of our DAML there. So I have to specify in my DAML file a dependencies tag, and then I list the dependency that I have. If I have more dependencies, I have to add more entries within my dependencies tag. So if I have editing dependencies, I add that in there and so on. So if I have an add-in example that changes another add-in, let's say I have two add-ins, then I would use the other add-ins add info tags ID attribute as identifier. And Uma earlier in the demo showed you that in the metadata add-in info tags data, there's always an ID tag. It's a GUID. So that's what you would specify here. So in this case, for an add-in, I specify my dependency of a GUID. So I need to know what the GUID is of that add-in I want to change. So how does the UI work in ArcGIS Pro? The ArcGIS Pro UI is contextual. It's implemented through states and conditions. So what does that mean, the UI is contextual? Well, you see a little sample of that below. You have a layout specified. If that layout is active, then within Pro, you now suddenly see a layout tab appear on the ribbon. If you activate a map, then that layout tab would disappear. This is what we mean by the UI is contextual. There's a state within ArcGIS Pro, and we have conditions that kind of know what the state is that drive our UI. So a little bit about states and conditions. States and conditions are used to simplify coding. There's no event wiring like we have with more traditional models. So the example would be a button is enabled only when a certain sample state condition is true. And then states are named values that describe a particular aspect of the application's overall status. And states can either be activated or deactivated. So there's two states. Activated being true, deactivated being false. That's the way I remember it. So, and conditions, now conditions are different from states. States is what you have within your code logic. Conditions is what you define in your DAML. So, conditions are expressions that are composed by one or more states. And you can use and, or, not logic. If you look in the extension DAML files, you can see a lot of these conditions that are fairly complex when you look exactly at all the states that they are considering. So they're used for triggering the activation and deactivation of framework UI elements. And we're going to show that again in our next demo. Now, what I have to do in code is, in my DAML, I have to, under conditions, insert my own condition. I name that condition, and then I define the state. In this case, my condition is true when my state with this ID is true. It's a very simple condition the state true, false, the condition is true, false. But I could have an and or logic or not logic in there if I want to. Now in my code behind, in my business logic, I would drive the state itself. So with a certain name, I check, is it active? Then I deactivate it. Or is it not active? Is it deactive? Then I activate it. So this is my toggle state logic here, where every time I execute that piece of code, my state flips from true to false and vice versa. Now finally, how do we utilize that condition in our DAML? For each user element in my DAML, I can define a condition attribute. If I specify the name of my condition in there, it's using that condition to drive whether it's enabled or disabled. So again, how do I use existing Pro UI elements in our add-in? I can use anything that exists in Pro in my own add-in. So I can use buttons, tools, galleries, whatever Pro has, I can use. All I have to do is I have to find the unique element ID of the existing Pro control and then use that ID in my config.daml markup to either add, delete, or modify that element. So next we have a little example down here. In this example, we add Pro's Navigate Bookmarks button to my own add-in toolbar. So the syntax for that would be, I have a button tag that references the existing element ID. The element ID is Esri mapping, bookmarks, navigate, gallery. Well, there's a mouthful. But anyway, so here in my group, see this is my own group. I have a group called hooking commands. And within that group, I have a button element, and all I specify is a ref ID, a referenced ID, and I reference the existing ID from within ArcGIS Pro. Now, you can see on the right side, that's my toolbar. I added 2 more buttons to it, but on my toolbar, the existing bookmarks navigation button appears. And we'll see that in the sample. So now the question is, well, how do I find the element ID, right? So we have multiple ways for you to find that. One way would be to use our documentation. So if you go to our documentation wiki, you can see we organized all the DAML ID reference by extension module. So these are all the extensions that we currently support in our API. One of them is the mapping extension. So you click on the mapping extension, and then you'll see within the DAML ID reference for the mapping extension, we organized it by controls, which are buttons, combo boxes, checkboxes, etc. We have categories, conditions, galleries, and so on. So if I want to find something, I can either scroll through. Each one has like a name, which is like a short description, what it does. You know, some of them might not make much sense, but what you can always do is you can go back to the DAML definition file of that extension and look up more on that, right? You now know what it's called. So if I look, for example, for navigate bookmark, and search for that, you can see that, well, did I misspell that? No. I guess my find is not working anymore. I'll just scroll through and see if I find something. I guess not. Navigate, bookmark. Thanks, Uma. There we go, that worked better. Okay, is bookmarks navigate? There we go. It's no wonder I couldn't find it. So maybe my find is still working. So here we go, that's our button. So I can find it this way. That's one way of finding it. Let me close this, go back to the slides. We also have a tool that comes with a Pro SDK. It's called the Generate DAML IDs tool in Visual Studio. You see over here, when you right-click on your project, you can use this tool to generate all DAML IDs. It will generate a source file with all DAML IDs that exists in your current Pro configuration. And then this will allow you to use IntelliSense to find the IDs. And the way you use the IntelliSense is you start out with DAML.button. And then everything within ArcGIS Pro starts with Esri underscore and then the extension and then underscore whatever the button does. It's kind of standardized that way. So this is how you could find something as well using IntelliSense. And finally, let me go back. Previous. Got a little bit excited there, clicked on the screen. So finally, we can use the ArcGIS Pro itself. There's an option for the customize the ribbon. So you see a screenshot of the options here. If you scroll all the way down to customize the ribbon, there's a checkbox that you can check. It's the show command IDs on screen tips checkbox. As soon as you check this, when you go back to your UI and you hover over a button or command or tool, you can see with a tooltip the ID of that specific button or tool will be listed there. It's kind of hard because you will have to type it in and don't make a mistake while typing in, but at least you know what it is. Okay, first demo. We're going to show a whole slew of things utilizing a project that we have available on our community samples. It's called Working with DAML. And let me make this big screen here. So this is the Working with DAML example. Again, it's available. You can try it yourself. You can download it. So let's look at the config.daml first. This will demonstrate some of the features we just seen. So first of all, I want to modify the mapping user interface like I mentioned earlier in my slides. Since I want to work on that, I have to establish the dependency to the mapping extension. So here's my dependencies tag. And as you can see, I specify dependencies add mapping.daml. Referencing the DAML file that's used by the mapping extension. So now I know that my add-in, since I have established this dependency, will have the last word on the mapping UI. So next I specify a condition. This is a straight copy and paste from the slides. The insert condition's name is example state condition, and I'm gonna find this here because that way we can see where else I use this in my config.daml. So I'm going to use this condition on my UI to drive the visibility of my UI. And again, just like I showed in my slides, I only have a simple state. If that state is active or deactive, my condition will turn true or false. And we'll see the code behind for that in a little bit. So a very simple state. So let's scroll down a little bit here. So in my module itself, I create what's called a tab group. A tab group has 2 tabs. So here's my tab group. I have 2 tabs in there. One tab is called Favorite 1. The second tab is called Favorites 2. This would be where I would organize the buttons, the tools for my specific workflow. You know, if I have to do a selection and then maybe an overlay or whatever, I can put all my buttons right there in line so I can do my workflow that I need to do. So, but you can see that the Favorites 1 tab has a condition. So only if that condition is true will I see that tab. Otherwise, that tab will not be seen, just like we noticed earlier with the layout tab. So the second Favorites 2, same thing. It also adheres to that condition. Only if the condition is true will I see the Favorites 2. The Favorites 1 has 2 groups of buttons that I define manually below. The Favorites 2, I don't even define reference just an existing group of buttons from the mapping module, which is the inquiry group. And we'll see that when we run it. It will be very visible. But for my first groups, I have a whole bunch of buttons that I reference from within ArcGIS Pro. I don't even define any code. I define nothing. I just say, I want to have a project button. I want to have a bookmarks button. I want to have a context menu export button. So that's all I want in my first group. And my second group, I have a bunch of selection buttons. So again, I have no code, nothing, just referencing existing ArcGIS Pro functionality. Now I define my own button that will drive my states. So I need something where I can enable the condition that then shows me my tabs, right? So that, button is called the toggle state button. And we look at the code behind for that shortly. So what do I now do is, on the very bottom, I update a module. So I don't insert a module to get a new tab. I update the module. And the module I want to update is the Esri mapping module. So I'm going to change the mapping. And just like in the slides, I'm going to update groups. Specifically, I update the Esri navigate group, the mapping navigate group. And within that, I'm going to delete the Esri mapping bookmarks navigate a gallery button. And then I insert my own button, the working with DAML toggle button that allows me to play with my user interface. When you see the sample running, it will be clear. It's a little bit confusing now, but trust me, it will be very clear. And it is very powerful to implement these patterns. So here's my code behind, same code that you saw on the slides. We pretty much have a state that we toggle true to false and false to true. If that state is true, then I deactivate it. If it's false, then I activate it. By default, it will be false. So we won't see anything. My condition will be false, and hence my tabs that I insert will all be invisible. So let's try this out. We're going to run this sample. Okay, I rebuild everything. I run the debugger. And again, except for my toggle button, I haven't written a single line of C# code. I only reference existing functionality from within ArcGIS Pro. So let me, I think it doesn't matter what I open. So I'm going to open a project here. Now here, you can see the contextual UI. I have a map highlighted. So I have a map active. You can see I have a map tab here with all its functionality. If I click on the layout, you can see the layout is active now. The map tab disappeared. Instead, I have a layout tab now. So this is the contextual UI. So let's take a look at what the button group for the mapping looked like before. I have a screenshot right below. So this is what it looked like before. You can see the explore button still there. My zoom buttons are still there. But the bookmarks button that I didn't like, that I deleted, it's gone. Instead, I have the go to XY right there. I have the go to XY on the old default standard Pro screen as well. So let me close that. And now we can see here is my toggle state button. Right now, you see my user interface is pretty much what you get out of ArcGIS Pro, with the exception of the bookmarks button that we deleted. Now, if I click on that toggle state button, it will step into our code, in our code behind. So we can see right here, this is where I check the state, my example state. I'm going to step over this. So it was not active, and now I activate that state, which will set my condition to true. And if I continue running, you see suddenly we have a new tab group up here, my example state solutions group. And I have my favorites 1 tab and my favorites 2 tab. Let's go back to favorites 1. Favorites 1 has 2 groups of buttons, group 1 and group 2. You can see all these buttons you see here are all borrowed from within ArcGIS Pro. So here's my bookmarks. I can go through my bookmarks functionality. Here we go. I can create a new map. I can do a selection. So this is all functionality that I put on my own UI through just coding the DAML. And when we look at favorites 2, this is where I just referenced a whole group of buttons. So if you look at the inquiry, if we look back here on the map, so on the map tab, you can see the very same inquiry group exists on the map tab. So I simply duplicated it, but you can, you can see the contextual UI still maintains all the contextual functionality. So the infographics is grayed out because at this moment I cannot use it. I don't have the right context for that button. So this concludes this kind of demo working with DAML. Again, we have the sample online. You can play with that sample. You can do wild stuff with that without having to code C#. So I'm going to close this. Back to the slides. So the next pattern is the asynchronous programming. If you come from a ArcObjects world, you know that ArcObjects is not asynchronous by nature. You can write your own threading models for ArcObjects, but that's very tricky. ArcGIS Pro is a multi-threaded 64-bit application. And the main motivation to use asynchronous programming was to keep the user interface responsive. So if you remember from ArcObjects, if you had any kind of lengthy operation where you didn't implement your own yielding or your own background threading, you would usually get the not responding text on the menu, and then your UI was not responding, was dead, right? And then you just had to wait until it recovered eventually, and then you were fine. So in Pro, that's not really the case anymore. So in order to do this, there's 2 important asynchronous programming patterns for the SDK that we should know about. One is the use of the async and await functionality in C#. That's, it's out-of-box .NET C# functionality, VB.NET as well. It's not something that is specific to our SDK. What is specific to our SDK is using the ArcGIS Pro Framework's QueuedTask class. And I'm going to explain that in a little bit. So the Pro internal threading model, ArcGIS Pro's multi-threading incorporates the latest asynchronous language features from Microsoft. So if you want to go ahead and do your own Microsoft background thread or worker threads or whatever you're used to, you can do that. It's not something that we have a specific purpose for, but if you want to do that, you can. We completely integrate with Microsoft's asynchronous features. So the ArcGIS Pro SDK developer only needs to worry about 2 threads. So you need to worry about the graphical user interface thread, the GUI thread that's in the foreground where it responds to your UI. And then there is a single specialized worker thread called the main SIM thread. SIM stands for the Cartographic Information Model. You see that term a lot within the API of the Pro SDK. Main SIM thread we usually abbreviate with MCT. After a while, you know all these terms. Takes a while to get used to it, but eventually they'll be very familiar. There are 2 categories of methods within the ArcGIS Pro API. We call them coarse-grained asynchronous methods, And asynchronous methods can be called on any thread, so you don't need to worry about where you call them from, background thread or GUI thread. You can call them anywhere. Once called, these methods return to the caller immediately, but execute asynchronously in the background. That's the nature of an asynchronous method. So fine-grained synchronous methods, these must be called using the QueuedTask class, which we explain on the next slide. These methods are blocking and return to the caller after the method is finished doing its work. So if you would call one of these, or if you would be allowed to call one of these on your GUI thread on the user interface, it would be blocking. You know, it wouldn't return back to you until it's done with all its work. You don't want to do this because then your user interface is dead. You can't do anything. You cannot cancel. You cannot do anything. So hence, there's special processing for that. We'll see in a second. So first, let's look at coarse-grained asynchronous methods. Again, they can be called from any thread. Typically, you would invoke them from the user interface thread, though. Coarse-grained methods execute in the background, but they are internally processed on Pro internal threads. But that's hidden for you. You don't need to know about that. Coarse-grained methods use the async naming convention. That means that the names of a coarse-grained function always ends with the word async. And callers can use the async await semantic to pretty much fiddle with the nature of these functions. I'm explaining this by a little code snippet below. You can see I execute an asynchronous function below, geoprocessing function. It's a tool to perform a selection with a specific where clause. So I'm going to say, go into my parcels. I want to have a new selection. The where clause is description vacant land. And I want to execute that asynchronous. So I don't want to have my UI blocked. I'm going to use the asynchronous function. Now you can see in the next line, I say zoom to the selected set asynchronously. Now, the problem here is we know an async function returns to you immediately before it even starts processing in the background. If in my next line I want to use this selection, that would be a problem because who knows when that's going to finish. That where clause might take seconds or even, who knows, minutes, right? If you have a large data set, so it's a problem. So this is where the await syntax comes in. If I specify the C# await keyword here, what this means is, hey, execute tool async function, do not return back to me until you're completely done with your work. So I want to await until you're finished. So now I can go to the next line because when I use that selection, which is the result of my geoprocessing task, on my next line, if I want to zoom to that selection, I know it's actually complete, it's actually there, it will work. So that looks like a big task, but we're going to do a demo and it will become a little clearer when we do our first demo. So for this demo, what I did is, I did same thing Uma did earlier. I created an add-in. I added one single button to the add-in. You can see that button here. It's a class name test async. And if I look at the class itself, I can see that in my on-click for that, I call one method called coarse-grained methods. And when I look at my coarse-grained methods function itself, you can see pretty much a copy and paste from the slides earlier. I perform a selection, it's asynchronous, and hence it will return to me immediately before the selection itself is actually done. And then I actually zoom to that selected set. Now, well, this might not work. It doesn't always work, but hopefully it will work right now. I think this will not work. Sometimes it does work, so it depends on the speed of the network, all the environment and everything. So I'm going to rebuild this. I'm going to run it. Because this execute tool async function returns to me immediately before it even does the work, I don't think that the selection will be done by the time I call the second line. So let's run this and we'll see what happens. And these are asynchronous functions. I can call it from any thread. They execute in the background. So I should be able, while they execute, I should be able to click on the UI and still get a responsive UI. We're going to test that too. So here's my data set. Here's my async course tab. Here's my tab. Here we go. I'm going to click that button. And immediately you see the result. My coarse grain method is done. Well, where is my selection, right? Did it do my selection? Yes, it did. But it did it in the back as a background task after I called zoom to selection. See here, down here, here's my selection. So it did work. It did do my selection. However, I called zoom to selection without waiting for the selection to actually complete. So how can I solve this? It's very easy. As we showed earlier on the slides, I'm going to add the await keyword. Now, when I add the await keyword, now suddenly the compiler complains. The compiler says to me, hey, the await operator can only be used within an async method. Consider making this method asynchronous, blah, blah, blah. So I'm going to tell the compiler to do this. I can just click on that little help me fast resolution click there. And then I can say make this method async. I'm going to click on this. So now you notice it changed my method parameter. It changed it to async task, which, task is just a void, but same return parameter than before, but it's asynchronous now. Also, because it made it asynchronous, and this is our rule, it added the async string at the end of my method. So now I know this will not return to me because I'm awaiting its result until it's completed. So now I can do the same thing here for my asynchronous zoom to selection. I'm going to say wait for this. So now I should not get this result message box until the whole process, my workflow is done. So let me rebuild this thing. There we go. I'm going to start it. Uh-oh, somebody's breaking through the wall here. I guess I'm running out of time. That's why they want to get in. Here we go, coarse grain functionality. So I'm going to do the coarse grain here. And we can see now, while it's doing this, I'm going to click on the UI. We can see my UI is still responsive. It still comes back with something. And then when it's completely done, you will see I get my coarse grain methods is done prompt. Okay, back to the slides before they break in the wall. Okay, fine grain synchronous methods. So they must be called from within the QueuedTask class. There's a much greater number of fine-grained methods and classes. There's no async await keywords, and they actually run on the MCT, that main sim thread. So these are designed so you can write your own business logic as a background task. And the syntax will look like something like that. You run your business logic within the context of QueuedTask.run. And here, for example, you can see I have the select method for parcels. This is a blocking synchronous call, so I have to run it within the context of QueuedTask.run. So QueuedTask uses the Pro Framework's custom task scheduler. It's used to run blocking ArcGIS Pro methods. Oh, back. And they run on a background worker thread. Synchronous API methods are listed in the reference guide using the following text. Use QueuedTask.run. So you have to look out for that. Whenever you see this in the API reference guide or IntelliSense, that means it's blocking. There's example of synchronous methods. Most all of the geometry operations are such. And the way you use it is you say QueuedTask.run, and you either reference a action method or you specify the lambda within here. And now let's go to the sample real quick. When we look at the sample, I have again the same one button there. I have one fine-grained methods function that I call. On this one now, I have to, because when I hover over select, and I'm not sure whether that's visible, but you can see at the very end it says use QueuedTask.run. The same to my zoom to selected. These are the same functions that we used earlier as asynchronous. Again, I have to use QueuedTask.run. If I don't use this, it will throw an exception. So I have to uncomment my QueuedTask.run context on this. So let me do this. Again, the compiler complains. He says, wait a second, this function is now asynchronous, so I can use again the compiler to make it asynchronous. You can see it renamed it for me automatically. It also says now up here, this is asynchronous, so I can use the await functionality up here. So I should be able to see the on-click done method when it's complete. It will run in the background just like before. So let me run this real quick. There we go. Definitely this has been starting up faster in our practice because I see I'm over by 1 minute already. Excellent. Here we go, plenary pop-up, our sample data. Here's our fine-grained method. So this would be our own business logic that we wrote from synchronous functionality. This could be our geometry overlays, buffers, overlays, intersects, etc. So when I click this, it will again execute our business logic in the background. I can click on the UI while it's doing this, and when it's done, it shows me here on click done. So I just completed successfully a very simple business logic implementation that runs in the background. Back to the slides. There we go. And we have a few more sessions. There's one at 5:30. Wow, that's pretty late. Beginning editing with focus on edit operations, and you can see here maybe you can use the Esri events application too to see everything that we do for ArcGIS Pro SDK for .NET. And that concludes the demo. If you have the session, if you have any questions, see us at the Pro SDK tower, and we'll help you out with all your questions there. Thank you very much.